Hi, I'm Jason from the Dental Equipment Repair Channel. Today we're going to talk about a dental delivery unit and how the dental delivery unit arm brake works. The arm brake is the component that causes the arm to stay in space when the switch is activated. So when a dental unit is in use, there's a heavy-duty spring that helps maintain the position of the head with relationship to the floor and the patient. This head, it has weight out on the end. And just as if you tried to hold a weight away from your body, you would notice that that would start to wear on your larger muscles. So this arm, it's like a big muscle right in the middle of this thin delivery unit arm. And so what this brake does is it uses air pressure to lock it in place. Now, this particular brake has a problem, and that's why we're here today. We want to show you exactly what the problem is. We want to troubleshoot it by taking the component apart, and then we want to go ahead and give you a special bonus look on the inside of this arm and actually show you physically what the arm brake looks like. I know for me it was a real surprise to see it, and I know you're going to enjoy it. Let's hop into it. Looking at the delivery unit with the cover off, we can see several different components. Now, not to get concerned, there is a lot going on here, but the specific thing we're looking at is the arm brake control, and thankfully there's only two hoses going to it. This is the switch that you would see on the outside of the unit, and when we flip the switch, that's where we can hear the motion inside the delivery unit arm, and we can also hear a significant air leak. Now, I want to show you exactly where it's plumbed in. The way we accomplish this is we go ahead and follow the lines back. The first thing we observe is the color of the lines. These two lines are black. So we're going to go ahead and do a little bit of a tug check, and we're going to look over here on the other side of the unit, and we're going to see what moves. When we go ahead and pull on these, we can see the movement over here from this line. So that tells us that this line here has a connection over here. Now, there's also a T, and that T comes off, and that is the part that I can see comes over here. And we can tell exactly which line it is by seeing which one gives when we pull. This is actually an old air water syringe tubing, a dual tubing. And so the other tube, we can see when we move it, it comes up here, and then it actually goes inside the arm right here. So these two hoses connect. Now the way we can know for sure is by taking this hose and we actually pinch it in half. So now when we flip the switch, okay, nothing happens. Now when we release it, there's a change in noise. So we know 100% that this little tube right here is connected to this. This is a great troubleshooting technique for any other issues within the delivery unit. We'll listen for the sound when we move the switch. Then we'll pinch the line and we'll confirm that we have a different feel and a different sound. Okay, I can hear that. So now this tube does in fact go up the arm. Now to get back to our initial problem, we're hearing the change in sound here at the switch. In general, switches should not make a big loud leaking noise when they're activated. Okay, that's telling us that there's a significant problem. Now switches like the master on-off will bleed pressure, and they will make a little bit of an exhalation noise. But that's normal. This is not normal. So in order to remove the switch, what we're going to do is first we're going to power off the unit. So the first thing that we're going to do is we're going to go ahead and we're going to take this switch out. The way we're going to do it is one of two ways. Sometimes you can get lucky and you can wrench the switch free with your bare hands. Other times you need to use a tool. Now this tool is specifically built for this job, and it's called a panel wrench. If you look on the inside, there's a nut, and this panel wrench is designed to slip right over the nut, like so, and it allows you to remove tension from the back of the nut. Now this does two things. Number one, it gives you a very positive engagement with the nut itself, and the second thing it does is it prevents you from scoring up the outside of your unit. Because when you tighten it on the inside, if anything gets scratched, it's going to be on the inside where nobody can see it. So we're going to back off this nut a little bit, and then by that time, the nut on the front is loose, and we can go ahead and spin that off with our fingers. Now this is the Adec service manual. The Adec service manual has all the great information for this unit that is categorized in a very orderly fashion. And what you'll see is you'll find a way that all the valves are plumbed, you'll find all the O-ring part numbers, you'll find the description of operation and the theory of operation, you'll find troubleshooting processes, especially for older equipment like this. And if you're a service technician and you're not very familiar with these units, I'd highly recommend that you spend some time in this manual just going through it and trying to look and understand exactly how things are drilled and plumbed. This is really going to help you, because if you can understand exactly what is going on inside of the unit, and if you can understand what it was supposed to look like and work like when it was manufactured, you're going to be able to back work through all the many years of repairs and maybe some of the misrepairs that have been done to the unit. And you're going to have a lot firmer footing when it comes to time to work on these units for yourself. So for this switch, what we're going to do is we're going to first depressurize the system. It's already depressurized, but if it wasn't, we would check by actually moving the switch and seeing if anything happened. So we're going to go ahead and turn the system off. Now the way we're going to go ahead and open up the switch without pressure on it is there's a pin that is engaged through the threading, and we're going to simply shove that pin out. Now that's going to release the toggle, and it's going to expose the inner working of the poppet. So we're just going to take a tool. This is the DCI air water syringe tool, and you can use this tool or you can even use a paper clip. That's fine. So as we engage the tool, the pin will come out, and what you have to do is hold your finger above the switch so that it doesn't go shooting out. Now, luckily for me, the pin kind of dropped in there, and so I'll just leave it right there because that's a nice safe place for it. Now we're going to take out the actual toggle itself, and now we're going to work out the poppet. Oh, okay. That's interesting. That's our problem. Now, this is the spring that causes the tension for when we move the toggle, and this poppet is the poppet that takes that pressure from the toggle itself and applies it to a long stem that goes down. Now that stem actually goes way down inside, and it causes air to be ported. And on this is actually a relatively common issue to happen with these valves. The poppet has actually snapped. Now you can see a little brass shiny piece right in the center of that, and you can see the other brass shiny piece. Now that is definitely not a good situation, because the likelihood that we're actually going to be able to get that out is fairly slim. Now we can try a couple things. The first thing we're going to do is we're going to actually try applying air pressure with this concealed and see if we can pop it out. So I'm going to set these other little broken pieces off to the side here. And we're going to go ahead and apply pressure. And I honestly don't know what's going to happen here. It might not work, but we'll go ahead and try it. So I'm going to go ahead and put it over my palm so nothing shoots out, and then we're going to apply pressure and listen and see what happens. Oh, that actually sounded pretty good. So now let's see if we have a little pleasant surprise in here. No? Oh, okay. That looks like it's happy to see us. Let's go ahead and grab that. All right, how about that? How about them apples? So now you can see exactly what happened. This poppet actually separated right there in that little joint. Now the reason it failed there is because these poppets all have O-rings. These O-rings fit inside of a groove. Now that detent creates a natural weak point that's within the poppet. And so whenever you have a poppet break, it's usually going to break right there at the point of greatest weakness. Now, fortunately, we were able to pressurize it and get it out of there. But that's exactly what is going on inside of this switch here. Now, I don't know if there's a spring on the inside of it. Because there was a larger spring on the outside, I don't think there's one on the inside, but just to be careful, we're going to go ahead and tap it out and see if anything else comes out of there, because there could be other springs. So I don't think that's the case. And you now see what's inside of one of these switches. So we're going to go ahead and put in a new switch and demonstrate the unit operating in its proper way. All right, now that we've troubleshot the existing switch, the switch that we're going to put in is a DCI 7027. This is a three-way momentarily closed switch. It's normally open, meaning that the air is normally going to travel through the switch from the supply to the arm, locking it until the time comes that you touch the switch and unlock the arm so you can move it. So it's normally in a locked condition, as you would have a delivery unit locked typically during patient care or when the unit is not in motion. So the first thing we're going to do is, with the switch system being off, obviously, we're going to disconnect the lines and we're going to hook up the new switch. Now the new switch, it says actually normally open on it, which is very nice of them, so that you won't get it confused. And there's even some unique markings on it, which might mean something. Those little 3 hash marks, I haven't seen those before, but that's possibly what it could mean. So we're going to go ahead and, actually, I'm putting that on, and I don't like it because it's so loose. So I'm going to go ahead and actually cut the lines. All right, so you can see that these tubes are spread out a little bit. What we're going to do is take our side cutters and just cut those out. And now we'll go ahead and insert our tube. But first, what we're going to do is we're going to get some of these little collars to put on there. It's just a really good habit to get in. Now, these collars are different than the ones that were on there previously. And that's because the Adec collars are generally 2-part, because the hose is a little bit smaller. But these collars here work pretty good. And before I get super committed, I'm just going to go ahead and turn the system on and make sure that things work as I expect. Okay? So now, with the system, with the switch in place, without touching it, the arm is locked. Now, when we go ahead and activate the switch, we can move the arm around where we need to. And then in mid-motion, I'm going to release it and see that the arm stops. And then I'm going to put downward pressure, move it, okay? And that's going to just move around, okay, like it should. Now the only other thing that we're going to do is, before we put it in, you're going to notice that when you hold the handle, and if you were going to turn the lock off, you would probably hold with your hand and you would probably use your thumb to push down. Now the issue is that the unlocking motion is to the side. Now these switches all have the ability to go ahead and customize them for the place that they're actually going to be installed. Now these hoses on the inside, get that guy on there. These hoses on the inside are going to be best in a horizontal perspective with regard to the actual bottom of the case. Because of down where it's at, if you had this bottom bar pointing down or pointing up, it would collide respectively with the floor of the delivery unit or possibly the ceiling. So the best scenario would be for it to be the side. So let me show you how to go ahead and adjust this. First thing, we're going to go ahead and turn off the system and make sure that everything's bled down. And then we're going to go ahead and you can take off the nuts, or you can just go ahead and move them towards one another. And you're going to notice that there's a pin, okay? And the pin is basically where the switch moves. So we're going to take our air water syringe tool or another pointy device or a paper clip. And after we drop it, we're going to go ahead and push that pin through the delivery unit, through the switch. So just by pushing, that pin will emerge, and then you can grab it, and while securing the actual pin or the toggle itself, you're going to pull the pin out. Now we said that we're going to want this to be normally in the up position so that when we push down on it, it will activate. So we rotate it to the correct position, and then we reinsert the pin. All right, now this is a little bit of a challenge, but not impossible. So holding everything together and visually aligning the hole, we're going to go ahead and just try to push it through. Now once it starts to go, which that's good, but now the key is on the other side. We want to make sure that we get that hole lined up, and then we advance that pin all the way through. Okay, and once we can do that with our fingernail, or you can do it with the tool. Now it's not really going with my fingernail. So you can see, just going to use that Allen wrench to go ahead and apply pressure, and that's going to snap in there. The reason that's important is because the nut will not rotate without having that pin perfectly aligned, because if it's stuck too far or one way or the other, it's going to have a problem. Now this new switch came with new nuts, so we're going to go ahead and install this. The first thing is we're going to take out the top nut, and there's a washer. Now this washer actually stays on the inside of the delivery unit. Okay, it's not like other applications where you'd want the washer on the outside. So we're going to go ahead and insert that switch handle, the toggle, through, and then trying to align the washer, lock washer. We'll slowly advance that nut until we have enough threads on the outside to engage at least the full width of the nut. And then we're going to tighten this on the outside as hard as we can with our fingers, keeping everything as aligned as we can. All right, now once this is in place and everything's aligned the way we want it, we're going to take our panel wrench, and then we're going to go ahead and, keeping everything in alignment, we're going to use the panel wrench and we're going to tighten the inside nut. Now this is going to, again, keep us from damaging the outside of the delivery unit, and it's going to keep things looking very nice on the outside. So now we've got a switch where when it's time to unlock it, we can just push down and move the delivery unit. It's very ergonomic. So let's go ahead and test it out. So right now everything's locked. We push it down. We can release it. All right. Now this is a good repair. This is everything that we were wanting to happen that wasn't happening. Okay, so as a review, we had a bad momentary switch. The actual poppet broke in half, and it required a new switch. And so we were able to put that in, and we were able to check and get everything configured and set in a way where it would work properly. So now that we've covered this very basic repair, we wanted to get to the point where we can show you a little bit of a footage of what these actually look like on the inside and how they work. This is a really fascinating system, and I think you're going to like seeing how it all goes together. We've got a unit taken apart. Let's go on over and take a look at what we found. All right, so as promised, we have an old dental delivery unit arm here. Now, this has already been taken apart, so I'll try to kind of maintain the perspective of how it was assembled. Now, this unit is designed to have been like this. Okay, this would be inside the top of your post. All your lines would be coming up through, and then right up here is exactly where your delivery unit arm would be. Okay, and this portion right here would be, that pin would be through that pin, that hole, and then this would be right here. And so as you go to move it, there's springs in there that are strong, and they keep everything pushing away. And so there's a lock in here that's really fascinating, And so in order to access this, what we had to do was we had to remove these pins. We had to remove a pin from here and also a pin from down there. And by doing that, we were able to move the unit in a way where we could then go ahead and disengage this pin. And what that allows us to do is to remove this outer covering right here. And as that comes off, that's going to show the business end of how this thing works. All right, it's a little wild. Okay, now the way that this system works is we've got a spanner nut that will apply tension to this spring. Now the spring is really, as this thing gets more compressed against this nut, that's what gives it an increasing resistance to change. Now the lock mechanism, it's actually really fascinating. It's actually right here. It's these 4 little round things. And these are actually rubber coated, or they're some sort of cork coated, or some kind of coating. And there's actually a little barb right here. And the barb, what happens is the barb feeds into this channel, and there are these, whoa, it's a little bit of a dangerous one. This is perilous. All right, so there's those 4 little guys right there, and then what I was trying to show you is on the other side there's exactly 4. I don't know how to depict this, but essentially the way that it works is this inside here, right? It's actually upside down, but it's this way so you can see it. When those are filled with air, they push out and they cause everything to lock. Now the barb is on the other side, naturally. And what we're going to do is we're going to figure out how to show you this without seeing any of us get hurt. We've got an air line and a set of hemostats, and what we're going to do is we're going to disconnect the hemostats and clip lower. Okay. All right, so that's our test setup. Is a line with air in it, and we're going to go ahead and attach this right here, and we'll use the hemostats to go ahead and test this. So, like so. All right, now this is the fascinating part. All right, so see how loose that is right there? Now, what I'm going to do is carefully release the hemostats, and you'll see a change immediately. All right, so 3, 2, 1. Okay. Now that's locked. I physically can't move it. Those pistons, if you can see in there, those pistons are shoving out against the outside of that arm. I mean, this is probably so tight that there's no way we can actually win against this. I mean, we might have to do a test even to see how much weight it can hold, because we're all very curious about this. All right, so now to go ahead and get this off, we're going to go ahead and clamp it back off, and we're going to see if the pressure is going to bleed. Oh my gosh, that's so funny. I'm stuck. This is perilous, guys. I'm risking my life to show this to you. I hope you appreciate it. All right. Okay, so now that that's clamped off, it's still not moving. So I don't even know. I can't even get my fingers in there to undo it. So here's what's going to happen. I'm going to just yank this thing out. Or, you know, even better yet. Oh, it's okay.
I got you.
Oh, did you?
Yeah.
Oh.
Take the hemostats off.
Okay, we're going to take the hemostats off. We're doing stuff that's like so cutting edge that we have to figure out how to do it for you. We good over there?
Yep.
Okay. So now, as easy as that, it'll just come straight out. Now this is the thing that we were all laughing at earlier. I've literally never seen this myself. I've never seen this system apart, which might be saying too much. But we just thought this was hysterical. So I'm gonna. Easy. Whoa! All right. All right. Okay. So yeah, this was a thing. Whoa. Whoa.
Editing is our friend.
All right. Okay. So now we have pressure applied right here. Now, when I release this, you'll see the action of what keeps that in place. Ooh. Ooh. Oh my. Ooh. All right, that was interesting. I kind of wonder if we're standing on something, will it like lift us up? Oh my gosh, that was pretty significant. All right. Now here. Whoa. Huh. Do you have anything heavier?
At the drill.
I don't think I'm ready to sacrifice my drill on the altar of fun yet. What's the heaviest thing? No, not oil. That's a bad idea.
We're full of bad ideas today.
Oh. Maybe one of those brass impellers.
That's a good idea.
Ready? Mm-hmm. All right, this is a brass impeller. We're gonna try this. This is not light. All right. 3, 2, 1. I'm not making a lot of progress on that, am I? No? Oh no, I cut the O-ring.
Yeah, we're shorting O-rings.
Oh no, that's not good.
That one's gonna shoot real good.
Oh, it has a leak now. Oh, what? It's like whack-a-mole. So this is a pretty fascinating little thing here. So they all work together to stabilize this, and it's got all these little O-rings, and so it's just a block, and on the inside there's some little rubber, like little sliders here, and then it just has 8 of the exact same thing, and it's a hollow block and it pushes out. So I'm guessing that if this was ever a scenario where maybe you had a delivery unit arm where the only problem was that it was leaking, you could go ahead and pretty easily just find these O-rings and replace these O-rings. And also earlier where we were looking at this, we found that these little cork things came out, and theoretically you could take them and you could actually flip them around and end up with a whole nother gripping surface. So if you have a delivery unit arm, all you would really need to do is one at a time push them out and flip them, and I think you would end up with a scenario where you had fresh gripping surfaces. You just flip them one at a time. And now that whole thing has it's all refreshed. Those are, so here we'll throw the Hemos back on there right now. Now, just to kind of show, that's the difference in the color of those little stoppers, those little brake pads. And then, yeah, and you can see that's what happened when I was messing around. I cut that piece out of it. But all it is an O-ring, and so theoretically you should be able to get another set of O-rings, and then that's gonna be a piece you can change. Right? And then that end right there has been replaced. All right. And that end right there has not. So to compare, we'll just do that one more time. Flip that around, and that would just go straight in there. So I don't know, my view of so this has been a pretty fun little experiment. My view of delivery unit arms has really changed a lot. I honestly would say that I didn't really fully understand how they worked, and now that I've looked at how the braking mechanism operates, it's just a simple manifold with some brake shoes that push out and lock. The things we can do with it is we can replace O-rings, and we can also switch the brake shoes. We can also replace the tubing if it breaks. This doesn't look like that hard of a system to fix. The only thing that I would not really know about, and if any of you guys have any awareness out there, what do we do about the bushings when the bushings shoot out all that gold dust? Or black dust from when the bearings wear out. This seems like kind of the only really insurmountable obstacle that we just don't really know how to deal with, and typically end up reselling a delivery unit arm. So if you got some ideas on that, please chime in the contents. It was a little bit of a longer video, but it seemed like this was maybe one of those things that might have benefited to do a little bit of exploration and have a little bit of fun with something that we probably all should know more about than we really do.